So any questions on this one? All right, I'll leave that up for a few more seconds. This was an example when A is equal to 1. The next one will be an example when A is not equal to 1. Okay, for the next example, let's say if you wanted to solve 6x squared plus 5x minus 6 equals 0 using completing the square. Okay, so we know for our 6x squared plus 5x minus 6 equals 0, we know our A is equal to 6, our B is equal to 5, and our C is equal to negative 6. Okay, now we know for this one, for our first step, we know that A is not equal to 1, okay, which means we have to divide everything by that A value. Every term by A equals 6. So that means for our 6x squared plus 5x minus 6 equals 0, we're going to divide everything by 6. Both sides of the equal sign. Okay, anything divided by itself is just 1. So that gives us x squared plus 5 over 6x minus 1 equals 0. Okay, so we have the same equation, we just kind of tweaked it a little bit. So we're no longer going to use this one. We're going to use this one to complete the square. Okay, so now B is equal to 5 over 6. Your C is equal to negative 1. And finally, your A is equal to 1. Okay, so this is the one we're going to use. Okay, so now we have our A is equal to 1. We go to our second step, which means we just isolate our x terms. Okay, so x squared plus 5 over 6x minus 1 equals 0. We just go ahead and add 1 to both sides. Kind of separate that a little bit. So we have x squared plus 5 over 6x equals 1. Okay, so now we just complete the square of the left side. And third. Complete the square. Remember, we're using this one now. We're not using that one. Okay, kind of separate that a little. So you have b divided by 2a squared. Okay, so our b is 5 over 6 divided by 2a, so that's 2 times 1 squared. And instead of 2, remember you can just make that 2 over 1. Okay, so that means we have our first fraction. Division changes to multiplication, then you flip the second one. So you have 5 over 12 squared. Okay, remember, just before you apply that square, you remember that value. Okay, So 5 squared is 25. And 12 squared is 144. Okay, so that's the value you're going to add to both sides. Kind of separate those two. All right, so that means for our fourth step, you have x squared plus 5 over 6x plus 25 over 144 equals 1. That's the one over here. Plus 25 over 144. Okay, and if you did everything right, and you remember that value, this just becomes x plus 5 over 12 squared equals, and we'll solve that kind of on the side, 1 plus 25 over 144. We can just make that 144 over 144. That's 144 over 144 plus 25 over 144, which is 169 over 144. Move that up a little bit. Okay. So now you just go ahead and use the square root property to solve those. So x plus 5 over 12 squared equals 169 over 144. Go ahead and square root both sides. Oops. Shorten that up a little bit. There we go. Okay, so we know our square and our square root cancels out here. So we have x plus 5 over 12 equals the plus or minus square root of 169 over 144. All right, and instead of trying to cram everything here, I'll just continue this on the next page. Okay, so I'll leave that up there for a few seconds. Yeah, that's going to be the next step.
Oh.
Let me rewrite that last. Alright, so for our next step, we just kind of left off there. Okay. So we know that square root of 169 over 144, you can just factor that to become the square root of 169 over the square root of 144, which is 13 over 12. Okay, so this will actually become x plus 5 over 12 equals plus or minus 13 over 12. And if we subtract our 5 over 12 from both sides, these two cancel out. You have x equals negative 5 over 12 plus or minus 13 over 12. Okay, which means you have two answers. Which means that x equals negative 5 plus 13 over 12, or negative 5 minus 13 over 12. Okay, kind of draw a little separator there. Okay, negative 5 plus 13 over 12. Negative 5 plus 13 is negative 8 over 12, which simplifies to be negative 2 over 3. And negative 5 minus 13 is negative 18 over 12, which simplifies to be 3 over 2. Negative 3 over 2. Okay. So that means x equals negative 2 over 3 and x equals negative 3 over 2 are your answers.
Wouldn't the first one be positive 8? You're doing minus 5 plus.
Oh, yep, it would be positive. I was jumping ahead in my mind. Thank you. Yep, so it would be 2 over 3 and negative 3 over 2. All right, any questions on that one? All right. Leave that one up for a few seconds. Alright, so next we're going to go into the quadratic formula, which you hopefully remember. X equals, clean up that equals a little bit. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's your quadratic formula. Okay. Now, I provided a proof of the quadratic formula. You don't have to know it or memorize it or anything. I'll just kind of leave it with the notes if you're interested. It'll be scanned. Some people want to know, where did this come from? Some people don't care. I figured I'll give you the option. Okay, so let's say, for example, if you want to solve 2x squared minus 5x minus 3 equals 0 using the quadratic formula. And I might as well capitalize that Q. Oh, thank you. Okay. So for this one, it's pretty straightforward. You identify your A, your B, and your C, and then you just plug it into the formula. So for 2x squared minus 5x minus 3 equals 0, your A is equal to 2, your B is equal to negative 5, and your C is equal to negative 3. Okay. And then we just go ahead and plug it in. X is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So that means negative b is going to be negative 5 plus or minus the square root of b squared. So that's negative 5 squared minus 4 times a times c all over 2a. Okay, so that's going to equal negative of negative 5 is positive 5 plus or minus the square root of negative 5 squared is 25 minus 4 times a times c. So you have 4 times 2 is 8. 8 times 3 is 24. Negative negative is positive, so plus 24 all over 4. Shorten that up a little. Okay, so this will become 5 plus or minus 25 plus 24 is 49. So you have square root of 49 all over 4, which becomes 5 plus or minus 7 over 4. Okay, so that means that x can equal 5 plus 7 over 4, or x can equal 5 minus 7 over 4. Kind of separate that a little bit. Okay, so all we have to do is solve each one. Okay, so you have 7 plus 5 over 4, which is 12 over 4, which is just 3. Kind of separate that. And you have 5 minus 7 over 4. So x can equal negative 2 over 4, which is negative 1/2. Okay, so in this case, x can equal 3 or negative 1/2. All right, so any questions on that one? All right, I'll leave that up for a few more seconds. All right, so next we're going to look into, we'll take really a closer look into the b plus or minus the square root of b squared minus 4ac all over 2a. We're going to look at that part because b squared minus 4ac is your discriminant. Okay, so the first rule of discriminants is when your b squared minus 4ac is positive. Okay, so when b squared minus 4ac is positive, okay, so if it's positive, we know for a fact we have two real solutions. There are two different real solutions. Okay, so let's say, for example, we know that x is equal to negative b plus or minus the square root of b squared all over 2a. Let's say if our b is equal to negative 2, let's say x is equal to negative 2 plus or minus the square root of 11 all over 6. Okay, so that means that x can equal negative 2 plus square root of 11 over 6, or x can equal negative 2 minus square root of 11 over 6. Okay, so you have your two solutions, or two real solutions. Okay, so that's if your discriminant equals any positive number. Okay, so let's say second, if our discriminant is equal to 0. So when b squared minus 4ac equals 0, you would just have one repeated solution. Okay. So let's say, for example, we know our x is equal to, say, negative 5 plus or minus our b squared minus 4ac is 0, so it's plus or minus square root of 0. All over 2a, and we'll make that 12. Okay. So we know that just means that x is equal to negative 5 plus 0 over 12, and x is equal to negative 5 minus 0 over 12, where both of those are just negative 5 over 12. Okay, so it's just one solution repeated. All right, any questions on that one? All right. Leave that up for a few seconds. I'll finish up on the next page. Okay, so third is when your discriminant is a negative number. So when you know your discriminant is negative, you know that there are two complex solutions. Or in some cases they may say imaginary. And those solutions are complex conjugates of each other. So they're complex conjugates of each other. And remember, complex conjugates are just the same number, but the sign in front of the complex number is different. Okay, so let's say, for example, you plugged everything in, and you ended up with x equals -3 plus or minus the square root of -5.